Okay, so intellectual flexibility is the word of the day. Let's go over the quiz. Black on black, that'll work for everybody.
Why is it always a bike? I can't draw a bike.
Sorry.
It's so bad.
Okay, here we have just a kicked, so we have a lunch pail sitting there, and it gets kicked off a steel beam. The steel beam is 3.5 meters off the ground, and we know that it's kicked with an initial speed, and of course we know that that is on the x-axis entirely, because it's kicked horizontally, is 1.50 meters per second. What we want to know is, where does it land? So what's its delta x? Okay, do our little xy dealy. Delta x is what we're after. Delta y is negative 3.50 meters. Let me move that over. Vxi is 1.5 meters per second. Vyi is 0 meters per second. We have no acceleration on the x-axis. All of our acceleration is on the y-axis, and delta t will be our bridge. Okay, so on the x-axis, we're looking for delta x. Do we have something that connects Vx, delta t, and delta x? Of course we do, our old standby. Vx equals delta x over delta t. Rearrange it. Vx times delta t equals delta x. And we know that we're going to substitute into that one because we're looking for delta x. So now on the y-axis, do we have anything that connects delta y, vy, I, acceleration and time? Sure we do. Delta y equals, and it's vi, you know what, we'll skip the formalities. You all know that vi delta t goes away. So we have delta y equals 1/2 a delta t squared. Solve that for delta t. 2 delta y over a square root is delta t, and that whole thing gets stuck right into there. Okay, so we have v sub x times the square root of 2 delta y over ay is equal to delta x. And when we plug everything in, we get 1.26085, etc. meters is our delta x. So it sig figs out to 1.27 meters is our delta x. Okay. If you didn't get it, are there questions? Are there things that you don't understand how we did it? Okay, number 2, you ride your bike off this, horizontal ramp that you've built. There's your bike. You land 2.6 meters out from the ramp. What we want to know is how high the ramp is, and you go off with an initial horizontal velocity, Vxi, of 7.5 meters per second. Okay. So on the x, on the y, delta x, 2.6 meters, Vix, 7.5 meters per second, delta y is what we're after, ay is negative 9.81 meters per second squared, ax is 0, viy is 0, and delta t will be our bridge between the two. Okay, so what equation can we create on the x-axis? Well, we can, or what equation can we use? So Vx equals delta x over delta t. Are we going to plug into this one, or are we going to plug into the equation on the y-axis? Plug it into the equation on the y, because what we're looking for is on the y-axis. So we're going to create an expression on the x that we can then insert into the y. Okay, so delta y equals 1/2 a delta t squared. And basically we're going to rearrange this to solve for delta t. Delta t equals delta x over v sub x. And that goes into there. Okay, so we plug in our expression for time into our equation on the y-axis, and when we do that we get delta y of negative 5.89472. So your ramp, if we're going to call it that, is 0.59 meters tall. Not much of a ramp if you ask me. Okay, so we have all our variables on the x, all our variables on the y, creating this expression on the x, this expression on the y, solving and inserting, we get a Vx of 5.9 meters per second. Questions, comments, concerns?